Hello, welcome to the course Electronic System Design. Last few lectures we are discussing about how to design a PCB and what are its features. For example, we discussed high speed PCBs where the speed of operation is little bit high, and because of that high signal, what are the complications or what are the issues we face generally in electronic PCB design. So we saw some ground bounds, some impedance mismatch kind of stuff where a trace ends up at certain different structure, then whatever is that interface that act like a impedance mismatch, and wherever there is an impedance mismatch the signal gets bounce from that interface in the opposite direction. So there is a back and forth movement. Because of that we have certain issue, something called ringing. Then we discussed that for the parasitic capacitance and inductance and resistance we have in all the traces whatever we lay down, and because of these parasitic components the signal degrades, and because of that degradation there is something called signal skew which is very important for meeting the timing. That signal skew nothing but degrades our signal, and how do we quantify that? We use something called eye diagram, and we measure the jitter in that eye diagram or simply the opening of that eye. If it is more, then our circuit is better. If the eye opening is less or it is very small area where waveforms are not there, then it means our hardware is not capable of supporting that high signal. So these are some issues what we discussed last time. Today onward we are going to discuss the PCB design using the software. So we have many softwares available in the market which you can use for the PCB design. However, there is a very good software which is freely available, which is open source software. It's something called KiCad, KiCad, KiCad or KiCad, whatever you want to call it. So this KiCad software is open source software. You can download it free of cost for your personal use, and you can use any complex PCB. This is very state of the art software which you can use for all the commercial PCB design. You can implement, you can practice using this software, and you can design a very good PCB in this software. When you are done, you can use it just like any other professional software available in the market. You take the output and you can send it for manufacturing. So KiCad or the KiCad is a very widely used software which people use for designing the PCB as a hobby or the commercial PCBs. So today we are going to start this KiCad software and start designing PCB using this software. So the very first step is how to get this KiCad software or the KiCad software. So that we can simply do by searching on Google. So here we can write something like this. So we type on search engine that KiCad download. So this is going to show you the first, on the very first page you get this kind of website which is KiCad website, and there is a download option available on the front page itself. You can click on this, or you can directly go to Windows if you have Windows terminal, or Linux if you have Linux terminal, or you can directly go to this download KiCad EDA. Once you click on this link, this will lead to this KiCad website where you have multiple option of downloading this software. You have the Windows software, which is a Windows version. You can install it on your Windows machine. You have Mac OS based, where you can install it in your Apple or iPhone or iPad. Then you have this Linux based software which you can install in your Linux systems, and other formats are also available. So for example, we choose the Windows based software. You can click on this Windows. It will lead to the Windows download page where you have multiple servers where this KiCad software is available for download. So worldwide you can download it from GitHub, or especially if you have a local server available, let's say in Europe there is a server available here in CERN, Switzerland. In Asia you have other servers and so on. If you scroll this web page, you will get so many servers available where you can download this KiCad software. You just click on any particular server, just click on it and this will start downloading just like any other software. So once you download this software, this will be available as a exe file. You can save it in your system and then just install it like any other software. You double click it and go as just like you install any other software in Windows PC. So once you install it, this will create a desktop shortcut on your terminal where you can double click on it and you can invoke the software. So this is how you install this KiCad software. This is freely available. You need not to have any license or anything for this software. Just download from their website. So now we are going to discuss how this KiCad design flow is. So first we discuss the KiCad design flow and then we will jump to the software. How do we use that software? For that, actually in the KiCad design flow, we start something called a project, which is the very first step of creating a KiCad design. So we are going to discuss what are the design phases in KiCad design. So the very first is we start the project. So this is the very first step, project start. So this project start is when you start your software, your KiCad software, you put certain constraint or certain options which are suitable for you. For example, you want to have the grid size which is larger than its default size. So that you put in the very start of the project. You put the thickness of traces in schematic. So in schematic is just a wire which does not have any physical width or length specified. In the schematic is just a connection from one terminal to the other terminal. However, for visibility point of view, just to see this clearly, you can increase or decrease the thickness of this line, or you can change the color of that line. So all these options what you want to put in software before starting formally into a technical design, that comes under project start. So in this phase you put all those options, save the project as your starting point. The next step is the schematic design. So schematic design is the point where we import all the devices whatever we use, for example we use a LED, we use one resistance, we use one battery, we use one capacitance. So all those components we pick from the library and put together in a sheet, something called schematic. Once we put all these devices together, then we connect them using wires. So that design is called schematic design. For that we have a separate editor in KiCad. This is sometimes called EE schematic. EE scheme. So this is a short for EE schematic. So this is a software tool which is available in KiCad for schematic design. For schematic design, however, we need those devices. So we use something called the symbol. So to provide those symbols, for example, one LED has a particular symbol in KiCad. So from where those symbols will come? That will come from symbol editor. So we have something called symbol editor, which is a supporting software or supporting entity in KiCad. So in this symbol editor, for example, we are using a new type of device. Let's say we have developed a device for which we want to create a PCB. That particular device may not have a ready-made symbol available in the community, on electronics community. So those symbols you can create in this symbol editor and put it in the library. So for designing the schematic, you need the symbols of all the devices you are using. So you can pick the ready-made available symbols, or you can design your symbol in symbol editor and take that symbol in the schematic design. So this is the schematic design. Other thing which schematic design also need is electrical rule checks. For example, when we are done with this schematic design, we need to find out whether the design does not have any interconnection or something like that. For example, we have connected all these devices together, but because of some error or some mistake, some wires are overlapping the other wire or misconnection. So for that we need to have some electrical rule checker which can check all the electrical rules and find out if there is any error in the schematic design. So this schematic design also needs the input from the electrical rule check. So there is one more module which is electrical rule check. Or in short we sometimes call ERC. So when we create this schematic, we import the symbol from the library. If it is already available, then we take it from the library itself. If it is not available, it's new device or the device which is not available symbol in the library, we can create the symbol using symbol editor and take the symbol in the schematic. And when we connect all these symbols together, we need to find out whether we have done any mistake or not. Some more than 3 or 4 connections at the same node, which may be because of some mistake. So all these common issues, however, they can be checked and corrected using ERC or electrical rule check, where we define these rules. There are set of rules which are already defined in ERC. You run all those checks in your schematic, so the probability of having some error is lesser. Some of the errors this ERC can readily check. So once we import the symbols, connect them together and run the ERC, if ERC is also clean, that schematic does not have any problem and it is meeting the spec, that we do using our simulations, just like in LT Spice we did. So in LT Spice also we simulate using DC, transient and all other simulations. So that is what we perform in the schematic design. So once everything is clean, the system is meeting our design specs and this is also clean of any electrical rule check, then the next step from the schematic is the layout design or the PCB design. So the next step from here is layout design. So for this we have something called PCB new. There is a separate module in KiCad software which is used for designing this layout. So what this layout design does, when we have schematic is nothing but the symbols and their interconnection with each other. So this is the information schematic has. Once we pass it to layout, the layout, what this layout editor or layout design editor does, it takes up all these symbols and find out their footprint, their associated footprint. For example, we have used a LED in our design, schematic design. When we import it to layout, then layout editor will check the symbol of this LED and it will try to find out its footprint. Footprint is the actual dimensions of the pad what this LED has, this particular component has. So if this is available already in the library, then it will be taken as it is. Or if this is a different type of LED which the symbol is not available, then we need to define first the footprint of this particular LED if this is not readily available. So this layout design also has something called the footprint editor. These are the supporting modules. So this layout editor will check the LED which we are using in schematic. If this is not available directly, then it will be invoking the footprint editor where we can measure our actual component, or these dimensions are already available in the data sheet when we purchase these components from the market. So from the data sheet itself we know the dimensions, let's say 2 mil by 6 mil. This is the dimension of the pad. So that dimension we need to specify in the footprint editor, and we need to specify the landing pad pattern. What is the width, what is the length of these pads and how many pads we have, what is the spacing in these in between these pads. So all this information we need to put in this footprint editor and it will be going to generate these footprints. So to draw any layout from the schematic, all the devices whatever we are using in the schematic, they need to be associated to a particular footprint. For example, LED 1 has a corresponding footprint. Resistance have its own particular footprint, and that will be one-to-one mapping. It's not possible that one component, one LED may have two footprint. It's not possible, because we need to put one footprint in layout, and which one to put, that should be clearly defined for that LED. But there can be multiple mapping to a single footprint. For example, we are using two different type of resistance. One is 100 kilo ohm, one is 1 mega ohm. Both the resistance are different. One is 100 kilo, one is 1 mega, but on the dimension wise they are same, so they may have a same footprint. So the same footprint file can be associated to more than one devices. However, the reverse is not true. We cannot have two footprint on a single device. So this is how these footprints work. So if it is most of the time, what components we use, generally footprint is available in the library. KiCad has a very good library available, so most of the time we find out the associated footprint. However, it may be possible that it's not available, then we need to invoke this footprint editor to create our custom footprint. So once we have these footprints, these are particular to those devices, we take them into the layout design window and we put them together and make a complete PCB, or at least the layout for time being. Once we put them together, it may be possible that one design is mistakenly overlapping the other design, or certain design need certain margin on the left, certain margin on the right. There are, for example, we have some digital blocks and some analog blocks. By design, we do not want to have these designs mixed up with each other. One digital design should be one side and the analog part should be on the other side. However, if we do automatic layout or without any knowledge, then we can mix up these analog and digital blocks together. However, it's not a good idea. So all these design rules need to be checked when once we are designing this layout. So we have another module here, exactly like we have the ERC in schematic design, we have DRC in layout design, and this is called design rule check. Or this is called DRC in short. So this is a separate module which gives the input to layout design stage. So in layout design stage, we import the schematic and find out what are all the devices we are using in schematic. For that, we have associated footprints for all the devices. All those footprints will be imported into the layout design window. Once we put them together, it can be manually or it can be automatic. Once we put all these footprints together and we interconnect them, then we need to run something called DRC or design rule check to find out if there is any error or mistake in the drawing of layout. So once we complete this stage and everything is fine, DRC we run, that ends without any error, then the next step we go for exporting this PCB. So once we are done with this layout design, then we need to actually send this design for manufacturing, which is generally a fabrication facility where PCBs are fabricated. So to give this file to them, to those manufacturers, they accept a certain type of format only, which is called Gerber's or Gerber file. So once we are done with the layout, we generate Gerber files. These Gerber files are universally accepted for fabricating of PCBs. So we generate Gerber file. These files are nothing but the layout information. So these Gerber files has only the layout information what is going to be fabricated on the PCB. These Gerber files does not have any information about the schematic or any information about the electrical rule check or design rule checks. It is assuming that all those things are fine once we are generating these Gerber file. These are done in such a way because when we send our design for manufacturing to PCB, we do not want to disclose our design to those PCB manufacturing facility. So we generate these Gerber files and we send this Gerber file to manufacturing. From this Gerber file, it is not possible to backtrack our schematic design. So this is almost kind of impossible unless we provide these symbols and all these footprints. Then from Gerber file one cannot generate a schematic design back. So in that way we need not to expose our schematic to those manufacturers. So we generate these Gerber files. However, before sending them we need to first evaluate whether the Gerber file is correct or not. For that we have something called Gerber viewer. This is also a supporting module. So once we generate these Gerber files, we import that into Gerber viewer and there we can see all these information layer by layer. However, this Gerber viewer is just for the evaluation. Here we cannot edit these layouts. For layout, if we see any problem in the Gerber viewer, here the things are easy to understand. So in Gerber viewer we can find out any possible error which we might have done. So if there is any error we can go back again to the layout design. If there is any error we go back to layout design and we edit our layout design here, generate again the Gerber file and look at in the Gerber viewer. So this process repeats itself unless we found a Gerber file which is completely free of error. Once we generate this Gerber file which is now ready for manufacturing, then we send it for the fabrication. So once these Gerber files are ready, we take all these files. These are multiple files, one file actually for each layer and other drills and vias and other stuff. So we take all these Gerber files and send it to the fabrication facility where they are going to fabricate PCB based on these Gerber file. Once we fabricate these PCB, then it comes back to us and we complete our design using this fabricated PCB. So we can write this is the point where our PCB design ends. So we get the fabricated PCB and once we get these PCB we put all our devices and the PCB assembly actually work just like what we have designed in the schematic. So this is a complete flow of PCB design using KiCad software, and now we are going to see all these individual steps in the software where all these options are available and what are all other options available in KiCad software. So we will start one by one. Let's say for example we will start from the first and we'll go along into this workflow. So it's important to remember this workflow, and we'll be going to each and every step on the software. So let's switch to the KiCad software. So the KiCad software is available on your desktop. It will create a desktop icon where you can double click on that icon and invoke the software. So once you start the KiCad software from your desktop, the main window look something like this, where we have this KiCad name written on the top, and we have a browsing window on the left, and on the right we have multiple modules what we have just discussed in that workflow. For example, we have schematic editor, we have symbol editor, PCB editor, footprint editor, Gerber viewer, image converter, calculator tools, drawings sheet editor, and plugins. So we'll go to all these modules one by one. So the very first thing you should do when you start any project is go to the file where we have again now multiple options. The very first thing is the new project, where you start the project from the very scratch. When you start the project from very scratch, all the options will be by default whatever is available with the software. However, if you frequently use PCB design or frequently design all these schematic and PCB, so you have certain options which are tuned for you. For example, you want to have grid size always like 25 micron or 50 micron. So that you can put in the project and save that as a template. So next time when you start your project, you can design new project from the template itself, and all your particular options will be loaded into the project. So this is the option where you save your template and you use the same template for all of your design. So it makes the things little fast if you want to set your own template. Otherwise you can start a new project by default setting. So KiCad comes with some parameter values which are fine for time being. So we can start a new project by this. The third option is the open demo project. So there are certain projects which are already available in KiCad software which you can import in your workspace and learn from those projects. So there are multiple types of projects are available as demo that will be easy to understand the design flow. This is open project where you want to open your already designed project. For example, yesterday you have designed one project and you want to update that project itself. You can open right from here. And then there is a quit option. Next, we have multiple options. For example, schematic editor, symbol editor. These we will go one by one. There are preferences. So these are the preferences where you can put your default parameters. For example, we go to the preference tab. So here there are so many options which are generally put as default, but you can change all those preferences or all those parameters for your comfort. For example, the very common parameter which people change is the grid. Grid is the horizontal and vertical lines which guides you where, and it keeps your design neat and clean. So this grid size most of the people change, so that you can choose from any of these options and then do click on this OK. So the grid size will be changed as per your desire. So this is one option sometime people choose. The other option which people also changes is the colors of these multiple things. For example, the wires, the grids, the labels, all the things are associated with certain color in this window, and you can change any of these colors for that window. For example, the grid is actually given a color which is this gray type of color. You can move the cursor here, or you can choose any of the color by the color code or by clicking on this window and assign that color to that particular parameter which is grid. So here, for example, these labels, are nothing but when we write something for our understanding, that is a label. So that is given this blue color, so that generally people want to change to their different value. So all these parameters you can play around in this software, and you can change whatever you want to your comfort. And once you have this, then this becomes your project template. You can save this as a template, and next time if you start the KiCad software, you can directly import this project template, and all these parameters will be set to your desired ones. So there are so many options available, you can go along, but for a general designer, or if you are not going very professional, then whatever is the default parameters, those parameters are okay to start with. So we have all these parameters available in this KiCad software. So let's start one single project. So we click on file and we click on the new project. This is going to ask the name. You just write it any name to your new project and start writing this project. So this will ask you for a place where it want to save your new project. So we give it a folder and write any name, let's say example 1. So this is our name for our new project. We write the name and save this. So this project has now come here in the example 1 KiCad_Pro. So this project file is now opened in KiCad for the design. Now let's go one by one to all these modules, what we can do inside this module. So in this module already KiCad has generated two files. One is the KiCad_PCB and the other one is KiCad_schematic or SCH. So which is a schematic editor. So we can either double click on this itself, or we can directly go from the schematic editor to this schematic window. So this is the window and how it look like when we open a schematic editor. So let's carefully go to each and every option, whatever is the options available in this software for designing all these schematic. So the very first is very kind of common symbol which is the save symbol, where you can save whatever you have done here. These are some general symbols. Then we come to the important ones. For example, the first one is this zoom in, where you can zoom the workspace. This is zoom out, where you can decrease it. This is zoom to fit. Let's take 2-3 devices in the schematic so that we understand better. So we'll come to this step again. We are now taking something from the library. So for example, we have just randomly took 2 devices from the library. So it's easy to now look at all these options available. So this zoom in is nothing but you can zoom in from this button, or you simply keep your mouse close to the device or wherever you want to zoom and use the wheel of your mouse to zoom in and zoom out. So this is easy to do, zoom in and zoom out using your mouse compared to all these buttons. But let's say we have zoomed in and zoom out. If we want to fit everything into the window, then we have this zoom to fit, or simply the home button you can press and whole schematic will come into a single window. This is the zoom to object, where you want to zoom to wherever your objects are. So we have put only 2 objects, so the zoom in such a way that both the 2 objects will be visible on our window. Then we have something called navigate. This is the navigation button which we can use in case of hierarchical objects. For example, we have one schematic and the schematic is so big that we cannot put everything on a single schematic. So in that case, we make certain symbol of the entire schematic. Only the pin, input pin and output pin will be available from that symbol, and we use that symbol into another schematic window. So these buttons will be used in going one hierarchy up or down in that symbol. So we'll come to this point in a minute. These are the options to rotate your symbol. For example, I don't want to put a resistance in the horizontal direction, I want to put in the vertical direction. So these are the buttons to rotate the element or the symbol. These are for the flip in the x direction and y direction. Then this next option is the symbol editor. This symbol editor is, when you click it, it opens up something like this. So as we have seen in the workflow, the symbol editor is used to create symbols. So as we know, to make any schematic, we need to have a particular symbol for that device, whatever device we want to use in our schematic. So all these symbols, either they are already available in the library, or if we are having a new device which is not available or the symbol is not very common, so we have to make the symbol for that particular part. So we have opened this symbol editor. In this symbol editor, if you see on the left, there is a field library. So this is the library of all the symbols, and you can see there are so many, even thousands and thousands of symbols which are already available in the KiCad software. So for example, we go to any particular symbol. Let's say we want to check the diode. We click on the diode and it opens up so many types of diodes which are already available in the library. So very common diode which is used in the electronics is 1N4007. These are the diodes which are very widely used in all the electronics. So all these devices have already available symbols for these particular devices. So if we double click on it, it will open up the symbol of 1N4007. So this is the symbol we use in the schematic editor. We can import this symbol directly, 1N4007. Now for example, we do not want to use 1N4007 diode, which is the symbol is available. Let's say we have developed our own diode in our lab, or we have bought the diode from some vendor which is not very common, and the symbol is not already present in the library. That time we need to modify that symbol. So it's easy to modify the symbol if we have very similar symbol to that component. For example, we want to develop the symbol of a diode. So we go to any known diode, take out the symbol. For example, here we have taken this symbol, and now we edit this symbol itself to suit our requirement. So this symbol you can edit using all these editor or the symbol editor. There are many other diodes available which you can use for editing. For example, we have the CPU. Let's say this is the symbol and this is a editable symbol. So for example, now we have another CPU which is not exactly this CPU. So we need to edit our symbol in such a way. So we can here click on this thing and we can increase or decrease all these lengths to suit our requirement. So we have this pin, we can put this pin on the left or this pin on the right. So whatever we want to do to edit that symbol, that we can do in symbol editor. So all the devices, whatever we want to use in the schematic, those will be first generated the symbol. So either they are already present in the library or we can create the symbol for them. So this is the symbol editor. Here if we want to edit all these parameters, for example, we want to write the text or over this symbol, we can write so now this is the symbol for example underscore 1. So when we import this name will be visible, so we can easily understand that this is our device which symbols are not present in the standard library. So once we create these symbols using symbol editor, all these symbols can now be imported into the schematic. So we have multiple options like text. We can do multiple kind of rectangles or arcs or circles. So we can use any kind of symbol, or it's just like a drawing of the symbol, just like paint and brush. You can draw any kind of symbol which is just a visual representation of your device. It has nothing to do with your electrical rule check, or it has nothing to do with the physical appearance of your device. For example, a diode may look very different, but you can create a symbol for a diode just like a box. So one box, you can create a symbol for a diode. However, for the standard symbol for a diode is very much different than the square shape one. So this is the symbol editor which you use to create all these symbols. So once you make all these symbols using this symbol editor, you can now import all those components. The next option here is symbol library browser. So this is the library viewer where you look for all the symbols which are available. So this is the whole library. Here the filter is available. You can filter your search. For example, I want to search for a Zener diode. Okay, the Zener is not available. Maybe I will use some resistance. For example, we have, let's say, in the device section we have this R and C. So we go to device, then we go for the C, which is the capacitor, and the symbol is this capacitor value. We have, let's say, C polarized, which is a polarized capacitor, then we have this symbol assigned to that. This is the diode which is here. We go to any other classification just like driver FETs, and we have so many symbols available for all these different blocks. So these are the sub libraries, we can say. In this LED we have so many types of LEDs available which are already there in the library. So we can explore all these symbols, whatever you want to have. That is, first you should check here in the library if the symbol and footprint is available, then we can use them just like that. We need not to create separately the footprint and the layout and schematic symbol for that particular component. So there are so many symbols available here in this symbol library browser. So this is that symbol library browser option. The next one is the footprint editor. The footprint editor will go into the PCB design editor. When we discuss PCB design editor, that time we will discuss this footprint editor. So we are leaving it for time being. This is annotate schematic, where you want to write something and annotate something in your PCB. This is electrical rule checker. So this is the electrical rule checker. When we are done with our schematic, we have drawn the schematic, we have finalized our schematic. Then the last thing we do is electrical rule check. This is nothing but the set of rules which are already there in the KiCad software, and we run ERC, electrical rule check, to find out if there is any error in the schematic. So right now we have not made a proper schematic. So if we try to run this electrical rule check, this is telling me that there are so many errors we have found in the schematic, and these are like 25 violations of electrical rule check has been found in this schematic, which are very obvious because we have just put the devices, we have not even connected them together. So if you click on this, this will lead to where this error has occurred. So for example, if we zoom in on the devices and we click on this particular error, then this arrow is highlighted. So all these errors are nothing but the errors which ERC has found, the electrical rule check has found all these errors, and in these errors, if we want to find out where this error is coming, we simply click on this error and that particular arrow will be highlighted by this purple color, and we can directly go to that place and figure out what is the error which has caused this problem, this electrical rule checker flag. So we have like 25 errors found in this schematic, which is very obvious because all these pins we have not connected anywhere. These need to be connected to other devices, then only this electrical rule check will not flag. So this ERC is very important option where we find out if there is any problem in the schematic, and if there is any problem we go to that error location and find out what is the issue. So we sort that issue and then again run the electrical rule check till we find the schematic without any error. However, there may be some warnings, so sometime we need to think about those warnings, and if this warning can be acceptable or it's not acceptable. So warnings we can accept sometime, but errors are something where we look closely if there is any problem in the schematic and we try to sort those errors. So this is electrical rule checker button. You can invoke this from this button. The next we have the simulators. So this shows the simulation window where you can run SPICE software or IBIS simulations. So you can simulate right here itself. However, for this we have a dedicated software which is LT SPICE, which is very good for all these simulations. So we use, for the simulation we use LT SPICE. However, you can do here itself using SPICE or IBIS models. These are the assigned footprint. This we will go through this in the layout design editor where we will discuss that. The next is the edit symbol fields. So for editing certain symbol fields we use that symbol addition field. This is the next is generate bill of materials. So this is also an important function. When we create all this schematic, then we need to find out what are all the devices and components we are using in our design, so that we can go to market and purchase them or simply order them online. So we need to find out all the components, all their specifications, their manufacturers, everything needed to buy those materials, so that we can calculate from this option which is generate bill of materials. If we click on this, this is going to generate this output file. You can save output file by giving it a name here. However, in the preview itself it is showing that we have used these two devices in our schematic. Here we can see we have used these two symbols which are nothing but these two devices. These are the specification documents and all these, the part number, etc. Whatever we need to buy these from any marketplace. So this is something called bill of material, which we generally import from the software so that we can order them online, and when our fabricated PCB comes back as a PCB, then we can put all these components on the PCB and make it a workable PCB assembly. So here we can write the name of file and export, then it is going to export this file as a bill of material. So this is something called bill of material. So first let's take a decent schematic. Let's go to a demo schematic instead of making right away. Let's take a demo PCB and figure out all these options in there itself. So for example, we close this project and we take up a demo project which are already available in the KiCad. So once we click that, we have these demos in that demos file. Let's say we take up any demo project, let's say this flat hierarchy. We open this and open the schematic. So this is how this schematic look like. This schematic is read only because this is a demo project. If you want to have it editable, you need to save it in your local directory, then this schematic will be editable. For time being it's not editable, it's read only. So as we have discussed here, this navigate up and navigate down, it means this schematic, if we closely see, this is just two blocks, one is this and one is this. However, this one block is a complete circuit in itself. So how can we go inside this block and see what is there inside this block? We just double click on this and we will move into this block and see what that circuit is. So we double click on it and it will come out something like this. So inside that block we have this much of big circuit already there. So that's why these navigation up and down comes handy. So if we want to go up again, we click on this navigate up and we come back to the top view. Then if we double click on this, this is the circuit which is inside that second module. So we go up again and go into the first one. So this is how we can see these schematics and we generate the bill of material. So now we have so many devices which are connected here. For example, if we see, we have these Zeners, we have these op-amps. So many devices we have. So now if we generate the bill of material, we will have so many components which are already used in the schematic. So we can import, we can generate this output file and export it. All these components will come in that file. We can take that file and order all the components from the marketplace and purchase accordingly whatever we are using in that schematic. So this is the option bill of material, which is very important option. The next option is the switch to PCB editor. So this is the PCB editor. When we are done with our schematic design, we run all the electrical rule check, then we generate the PCB or go to the PCB editor or the layout editor. So this is the option for that. We'll go to that after some certain time. This is the scripting console. There are little bit of programming we can do to auto generate few things. So we'll not discuss that into this course, but this is possible to do some automation using the scripting console. However, this is rarely used in PCB design. The next options here are highlight net. For example, I want to go to a particular net and I want to see where all these nets are going. For example, this net PC underscore data underscore out, I want to see whether what are all the pins where this PC data out net wire is connected, so that I can highlight using this. I click on this and then click on this link PCB underscore data underscore out, and this net will be highlighted anywhere. If it is going to somewhere else also, this whole net will be highlighted, so I can figure out where all this connection are going. So for example, this look like a VGA port. So this pin number 4 is connected to one 10 kilo ohm resistance R3 and 10 kilo ohm resistance R4. So this is how I can find out where all the signal pins are going. The next is the choose symbol, where I can go and choose whatever component I want. For example, I want a resistor, then I just simply write RIS and this resistance will come out. So this is the symbol of that resistance. I can just simply click on OK and it will be brought to our schematic editor. This is the ground connection, as the symbol says. This is the wire. So once we connect one component to another, we use these wires. So we simply click on it and connect the two terminals using these wires. This broader symbol for wire is for the bus, where we have multiple wires running in parallel, that is bus, and this is from bus to the bus entry, where the bus terminate and goes to the another one, and all other symbols. So these are the most frequent used symbols in the schematic editor. So today we discussed the KiCad software, how do we install this KiCad software, and we saw the workflow where we start a project and then we specify certain options which are for our comfort, and we can use that as a template to load it into the new project. Then we go for the schematic edition, where we have just saw that how a schematic editor look like, what are the different functions into the schematic editor, what are the buttons we can use to create a schematic. We can go up and down, we can write the wires in between, we can generate bill of material, which is very important for the schematic design. When we design the circuit, we need to know what are all the components we need to order or the purchase from the marketplace, so that our PCB is complete. So by visually inspecting, we cannot figure out what are all the devices we are carrying. For example, in this particular example, we are using hundreds of devices. Visually we cannot find out what are kind of devices we are using, but we can generate bill of material and find out all the devices used in the schematic and their particular specifications, so we can go directly and purchase them. So these are some options which we use for the schematic design. Next we will discuss the how we design the PCB using the layout editor. So this is all for today. Thank you.